All right, let's talk about renewable energy, but not just the headlines. We're going to get right into the heart of it, the actual physics that turns sunlight, wind, and water into the electricity that's powering your screen right now. Let's jump in.
So how does it all actually work? I mean, how do you take something like a sunbeam or a gust of wind or the flow of a river and turn it into the very real power that keeps our world running? That's the huge question we're going to unpack together.
And you know, the crazy part is, the answer isn't some super complex, futuristic secret. Nope, it's actually grounded in one of the most fundamental and, honestly, elegant rules in all of science.
So our journey starts right here, with this one simple rule that explains everything from how a star shines to how an engine works.
Here it is, the law of conservation of energy. This is the master key, the secret decoder ring to this whole thing. All it really says is that you can't just make energy out of thin air, and you can't make it disappear. It just changes its costume. It transforms from one form to another.
So what this means is that every renewable technology is basically just a machine designed for this great conversion. Solar panels? They're built to convert sunlight into electricity. Wind turbines? They convert the motion of wind into electricity. And hydropower dams? Well, they do the exact same thing with the flow of water. It's all the same principle, just with a different starting point.
Okay, so let's get specific and see how this works in practice. We're going to start with the most massive energy source we have by far, our sun.
Solar energy is, well, it's pretty much what it sounds like, right? It's power we literally grab from sunlight. And the most popular tool for the job is the solar panel, which performs a little bit of what feels like magic, but is actually pure physics. This whole process has a fancy name, the photovoltaic effect, but think of it like this. Sunlight is like a shower of tiny energy packets called photons. When these photons smack into a solar panel's silicon cell, they transfer their energy to electrons and basically knock them loose. And what you call a bunch of electrons all flowing in the same direction? You call it an electric current. It's that simple and that amazing. Now, of course, to make this useful in our homes, you need a few more pieces. You've got the panels themselves, which create what's called direct current, or DC, but our wall sockets use alternating current, or AC, so you need a crucial little box called an inverter to switch it over. And more, you'll see a battery in the system to store up all that energy for nighttime or a cloudy day.
Okay, so from the sun, let's turn our attention to the sky itself. Our next source is wind, which, believe it or not, is actually just a byproduct of the sun heating our planet.
So wind energy is just that. It's the power we can capture from moving air. And the incredible machine we've designed to do that is, of course, the wind turbine. The process here is just beautifully straightforward. You see, anything that's moving has something called kinetic energy. So the wind, which is just moving air, pushes on those huge turbine blades and forces them to spin around. That spinning motion turns a generator inside, and voila, that's what makes the electricity. It's a very clean, direct conversion of motion into power. And if you look at the actual physics formula, you can see why wind times speed is everything. See that little v for velocity? It's squared. That means if the wind speed doubles, the amount of energy it's carrying actually quadruples. It's a huge deal, and it's why a strong wind is so much more powerful than a light breeze. All right, let's dive into our third major player, and this one's an old one, and an incredibly powerful one, hydropower. Hydropower is all about capturing the absolutely immense energy of water in motion, and we usually do that by building a dam to manage the flow of a river.
This one is a fascinating chain of energy conversions. It all starts with something called potential energy. All that water held way up high behind the dam has a ton of stored energy, just waiting. When the gates are opened, that potential energy is instantly converted to kinetic energy as the water rushes downward. That powerful flow of water spins a turbine, sound familiar? And that turbine powers a generator. And there's your electricity.
And here's the formula that explains it. It shows you what really matters. The mass of the water, m, the force of gravity, g, and most importantly, h, the height. It's pretty simple. The taller the dam, the more potential energy you've got stored up, ready to go. So we've covered the physics. Now let's step back and look at the reality of it all. How do these different technologies really compare, and what role are they playing in our world today?
This little table gives us a great snapshot. You can see right away that each has its own rhythm, right? Solar is a daytime thing, wind depends on the weather, and hydro needs a steady water source. Also notice that initial cost for hydro is way up there. I mean, building a dam is a massive project. But look at the payoff. Its efficiency is the highest of the three.
And this really gives us the big picture. The pros are huge. These sources are sustainable, clean, and cheap to operate once they're built. But the limitations are also very real. The biggest challenge is what we call intermittency. The sun isn't always shining, the wind isn't always blowing. And that is exactly why energy storage, things like massive batteries, is so incredibly crucial for a renewable future.
But don't get it twisted. This is not a far-off dream. This is happening right now. It's powering homes from rooftops, it's charging electric cars from wind farms on the horizon, and it's providing stable, reliable power for entire cities.
So, let's do a quick recap. The core idea is this. All renewable energy is just a story of conversion. Solar uses the photovoltaic effect to get electricity from light. Wind uses the kinetic energy of moving air. And hydro uses the potential energy of water held up high. It all comes back to that one single, simple rule.
And that leaves us with this final thought. The science isn't really the barrier anymore. The physics works, the technology is here, and it gets better every single day. So the real question isn't a physics question anymore. It's a choice about how we want to power our future.